Take a little bit of time and look at multiplying radicals. Now, I do have a bit of advice for you on multiplying radicals. Um, it doesn't have the politically correct sound to it, but it has a message that you will definitely understand and you will definitely remember. When you multiply radicals, there are outside numbers and inside numbers is the way I call them. Basically, down here at the bottom, let's just check this out. If I've got 2 square root of 3, and I'm going to multiply that times 5 square root of 7, then my outside numbers are these coefficients, 2 and 5. My inside numbers are the numbers that are underneath the radicals. So when I say outsides, I'm talking about coefficients. When I say inside, I'm talking about technically the word for the numbers under here are radicand, okay, because it's under the radical. So outsides play together, insides play together. They do not intermix. They are segregated. So you never ever multiply a coefficient with a radicand. They don't go together. Outsides only go with outsides, insides only go with insides. So if you can remember that these guys don't play together, that'll help you whenever you go through multiplying. Now, if there's not a coefficient or a number out front, then you might want to put a 1 there so that you don't get confused and do something that throws your problem off. That's the biggest bit of advice that I can give you to help with multiplying radicals. So let's kind of get started with these simpler ones. They don't even have coefficients, so if you would like to put the ones there, you could, but you don't really have to. All you have is radicands. So the 2 times the 8, go ahead and multiply those. That's going to give you 16. Once you have it multiplied, then you can go ahead and reduce. So the square root of 16, you know that is 4. You're done. Okay, now it works the same way with cube roots, not a problem. So just know that you're going to have, keep up with the cube. In all honesty, I have to remind myself every time I'm working with cubes or any other, 4th or 5th root, I have to remind myself to write down that root because I get in the habit of writing square roots. So if I'm sitting here as a math teacher needing to remind myself, just, know that you're in good company, that remind yourself, bring down that cube. So negative 5 times 25, that's going to be a negative 125. Well, that should be a number that you're familiar with. Now, hopefully the negative's not throwing you off. Can you do the cube root of a negative? So basically, can you have 3 things that multiply together and give you a negative? Because if you remember, 125 was in our list. Well, let's just give an extra step here to make sure that we're visualizing. 125, the cube root was 5. Think about it. Negative 5 times negative 5 times negative 5. Would that work? 2 negatives make a positive, so these 2 would cancel each other out, and then I would have 1 negative left over. Yes, cube roots can be negative. That's okay. That means your answer is just going to be negative. So not a problem for a cube root to be negative. Is it a problem with square roots? Yes, it is. Because the square root of negative 2, this is not real. So we're not going to proceed with this problem because this is not real. Now, later on, after you learn about complex numbers, if you were asked to reduce this in the complex number system, yes, you could. But if your question was to find a real answer, then that's not possible. If it just asks you to simplify, if you have knowledge of the complex number system, then yes, you could. So, for right now, we're just going to say this part is not real. If you want to get into the complex part, so just a little tidbit for later on, you could proceed and say, oh yes, that's going to be negative 16, and then what you do once you get there, the square root of negative 1, remember that's the I, square root negative 1 is equal to I, and that right there then you're left with square root of 16, which you know is 4. So you have 4i. All right. But that's complex. You may not be there yet. All right, let's kick it up a notch. These are cube roots, and they got a lot more interesting. Okay, so we have 5 times 54. That is not something I know off the top of my head. So grabbing a calculator, and we're just going to have to make our radical kind of extended. If you multiply that out, I got 270. Now, hopefully you remember your exponent rules. When you multiply like bases, you're going to add your exponents. And again, multiply your bases, and you're going to add your exponents. Now, hopefully you remember how to reduce radicals. If you don't, then go pull up that other video on reducing radicals, because that's what we're doing right here. You need to separate this. Let's go through the sorting process, because 270 is not a perfect cube. This 27 looks so good. Yes, 27 is a perfect cube, so you could take that and you could break it up in 27 times 10. Now, take your variables. Remember, you have to, basically, you're going to pull it apart. Pull this 5 apart so that we can divide by 3. So 3 of them need to go here, 2 of them there. You're basically taking the 5, step it down to the nearest number that's divisible by 3. So take the 7, step it down to the nearest number divisible by 3. That would be 6, right? So I need 6 here. That leaves 1 left over because these exponents need to add back up to that. So as we said in the other one, this will be left. It will remain under your radical. This is all headed out. The cube root of 27, no, that's going to be 3. Then we're going to divide our powers. That's going to be x to the first, and then we're going to have y to the second. And don't forget your little cube now. Oh yeah, y to the first. There we go. Good deal. And that's as good as that gets. All right, keep going. Now this one takes our little hint of insides play with insides and outsides play with outsides, because you actually do have some coefficients, and then you do have your radicands. Okay, so just multiply your coefficients. That's going to be 6. All right, then multiply your radicands together. Well, that's going to be 50x to the 5th, because we're adding our powers. Now, leave the 6 out here. He just has to sit out there and be patient, guys. Because this stuff underneath here, your radicand has got to be sorted out, and then you got to do the square root, and then we'll get back involved with the 6. But up until then, 6 just got to sit there. All right, we need a square root that goes into 50. I do believe 25 will work. We need 2 of them. Now let's see here. Since that's a 2, and if it helps for you to visualize it, put your little 2 there. I need a number divisible by 2. So basically, take the 5 down to the nearest even. That would be x to the 4th. You need 1 more. So all of this is set and ready to go. Now, depending on how well you understand this, you can leave some steps out. You can leave them all in. I'm going to show them all. But it's up to you once you start working your problems as to how much you leave in. Okay, this you have to take the square root of. Well, same thing as what we did before. Square root of 25 is 5. And you're going to divide your powers. This guy's stuck. Now, these things out here, they're both now coefficients. You multiply the coefficients together. So if you have numbers, basically, you multiply them together. If you have variables, then you're going to combine your exponents according to the rules of exponents. So 6 times 5 is 30. There's your x squared. He didn't have anybody to go with. And you just bring your square root of 2x along for the ride. Now, technically, remember, and I have a bad habit of forgetting it, so if I forget it, please forgive me. When you do the square root of a variable, you are supposed to put absolute value bars on it when he comes outside. Okay. And that is, if you were wondering the cause of that, that's because you can't have the square root of a negative. All right, same thing right here. That's going to be 6. And then 7 times 21. I'm not familiar with that one either. So let's just type that in and let's see what we get. 147. Okay, that's going to be x to the 6th and y to the 2nd. Okay, in all honesty, 147, doesn't ring a bell with me. This is the way my brain's working. I don't know if it works this way for you. There's a 7 sitting here. And it's all about factors, guys. 21 is 3 times 7, right? You have 7, you have 7. 7 times 7 is what? 49. So I'm going to take my little 147, and I'm going to type them in my calculator, and I'm going to divide by 49. And sure enough, that's 49 times this 3. It's perfect. But think about factors that compose your number, so you're not shooting in the dark. Then you come in here and take your variables. Well, everybody's even, so they're all headed out because both of them are divisible by 2. The only thing that's going to be stuck is your little 3. So your 6 is waiting out there. Square root of 49 is 7, and then you're going to divide both powers by 2. All right, so 6 times 7, 42, x to the 3rd y, square root of 3. And these need absolute variables. Okay? Hope that helps. Let me know if you need some more help and practice, and we'll come and look at it.